Hi, this tutorial covers a type of graph called a pictograph. A pictograph is a type of graph that has artwork embedded in them. Sometimes the artwork takes place of appropriate labels or numerical quantities and can be misleading or deceptive. So that's kind of one of the downfalls of a pictograph is that sometimes the artwork gets in play, kind of takes the place of really a lot of the good math that's going on with the graphs. Some of the benefits, though, of pictographs is that they are generally more pleasing to look at, and they also might draw in a a reader that generally wouldn't look at a graph. So there are some benefits to pictographs as well. So let's take a look at the first example of a pictograph. This is from USA Today. These are actually pretty common in that newspaper, USA Today. What it's measuring is USA's largest national forests, and these are being measured in millions of acres. And then there are five of the top or largest forests. So again, this is pretty visually appealing. You know, they put it in kind of this forest theme. It might draw the reader into it. But there are a couple things that are that I might have some issues with. So for one, there's really no scale. So we can't really, you know, if we're measuring 16.6 versus 2.7, there's no scale here to measure it. So you know, yeah, we aren't really quite sure if that's an appropriate measurement there. Um, the next thing, you know, where's zero? You know, is zero at the bottom, or is that more like one? Or you know, we don't really have an idea of where this starts. Um, and then the other thing, are we measuring the heights of those trees or the area? So we can see certainly that this is that Tongass, Alaska has certainly the largest, you know, bar, or in this case a tree. But is it largest in terms of area, or are we doing it in terms of height? You know, for all of these are pretty much straight across. So these are kind of a more consistent area. This really goes to a point, so it's losing a lot of area. So are we measuring the heights of the trees, or are we measuring the areas here? So those are just a couple things that might be a little misleading. Obviously, we can tell that this is certainly the biggest, but you know, there's not as much of a difference between these two. But again, are we measuring the heights or the areas? So that's just one example there. Here is another one. Again, this one is also from USA Today, and this one I kind of have similar issues with this. What we're measuring here is the ridership in billions of passenger trips on public transportation, so buses or trains. So in 2000, it was 9.4 billion. 2008, 9.5 billion, or excuse me, 10.5 billion. 2011 was 10.4 billion. So again, similar issues here. There's no scales on either the X or the Y. So it goes from 2000, 2008, 2011. I'd like to see a scale on the x-axis. Same thing on the y-axis. It'd be nice to see a scale. Also, we don't know where zero is. You know, is zero the bottom, or is zero up here? It's kind of hard to tell. And you know, these numbers aren't very far apart. So are they really representing that distance in the correct way? So those are just a couple, you know, same type of issues. There's no scales. We don't know where zero is. In this case, we're pretty certain that they are measuring the height. And then is this, you know, are we really getting a drop here? Or is that just because they wanted it to fit with this bus graphic? So again, there are a couple issues with this. But again, it's visually appealing. It might draw the reader in. You know, it has a bus, so it's being related to public transportation. So there are a couple good things, but also a few things that are a little bit misleading as well. So that has been the tutorial on pictographs. Thanks for watching.